Okay. So average rate of change. So I want someone to open up their journal. All of you can open up your journal if you want, but I need to know the I can statement. I need to know the I can statement for unit 2 or for lesson 2.4. That's that half sheet of pink paper. What do you have, sorry, Ariana? I can calculate, sir. It's as soon as you walk in every day. I can calculate. I even said that at the beginning. I hope that you guys got that. I can calculate the average rate of change given a specific, God bless you, domain interval. I can calculate the average rate of change given a specific domain interval. We often want to know how fast the outputs are changing compared to the change of the input values. This is referred to as, what do you think? It's referred to as the average rate of change. That's exactly what that is. Okay, so this is how you calculate the average rate of change. It says for the function y equals f of x, the average rate of change f of x changes from when x equals a to when x equals b is given by this formula. I know that this looks a little bit scary. This right here says the change in y over the change. That little delta, that delta symbol means change in x. But I want to talk about this. So this f of b minus f of a equals b minus a. So suppose that I gave you a table of values and I told you that the first ordered pair was a. If I let x equal a, what is my output? If I let x equal a, what is my output? No. If I let x equal a, what is my output? I replace the x with a what? Whatever you input. So what is my output? Okay, how about this? If I let x equal 2, what would my output be? What would I evaluate the function at? I would evaluate it at f of 2, right? You're just replacing. So if I let x equal a, my output is f of a. And if I let x equal b, my output is f of b. So all you're doing, all this means is you take whatever you get as the output for f of b minus whatever you get for your output of f of a over b minus a. That's all that means. You're just subtracting your two outputs over the subtracting the two inputs. Difference of the two outputs over the difference of the two inputs. So it looks scary, but it's really not. Okay. So we're going to use that idea and we're going to start working on some problems. So the doors to a movie theater open 15 minutes prior to the movie starting. The table below shows the number of people who have entered the theater as a function of time measured in minutes. So this is, whoops. So T is my input. So it's the same thing as an X. And N of T is my output. It's the same thing as F of X. Okay? So we have to find the value of N of 9, meaning when I input a 9, what do I get out? Minus N of 4. When I input a 4, what do I get out? So what is N of 9?
102.
So 102. That's what N of 9 is. Minus, what is N of 4? Okay. So what is 102 minus 32? What is 102 minus 32? It's 70. Okay. At what rate did people enter the theater from 4 to 9 minutes? So we're finding how quickly that happened. So we have to take the, not F, sorry. We're going to take the N of 9 minus the N of 4 over what I just input, which is 9 minus 4. We're just going to subtract them. So what did we say N of 9 was? Yeah, well, what is N of 9 minus N of 4? We just saw that. We said that that equals 70. And what is 9 minus 4? 5. What's 70 divided by 5? It's 14. It says show how you found your answer. So we did that and use the appropriate per rate units. So what are we talking about? How many people entered the theater? So 14 people entered the theater per, what is our time representing? How much is our time? What's the lapse in time per what? Time represents what unit? Alessandro, time represents what unit? Read it up at the very top. Time is what? What does it say at the beginning of the problem that time is? Time is what unit? It's minutes. So 14 people per minute. 14 people per minute. It helps if you keep your eyes open, bud. So on average, were people entering the theater faster between 4 and 9 minutes or between 9 and 15? So we know that between 4 and 9 minutes, we averaged 14 people per minute. We have to figure out the average rate of change between the 9 to 15 minutes. So we have to take N of 15 minus N of 9 over 15 minus 9. So how many people entered the movie theater at N of 15? 150. What about N of 9? It's 102, right? What is 15 minus 9? 6. 150 minus 2 is 48. 48 divided by 6 is 8. So in the 9 to 15, whoops, why did that change colors? That happened so quickly. In the 9 to 15 minute interval, we had 8 people per minute. Which one is faster? The 4 to 9 minute interval is faster. Okay. How do we feel about that? Good. Okay. So number 2. For the function f of x equals x squared plus 5, find its average rate of change over the following 2 intervals. So we're going to use our calculator. And we're going to put this into our y equals. So we're going to go to our calculator. And we're going to go to the y equals. So everyone pick up your calculator. Y equals and press clear. Hit the clear button. And then we're going to input the equation x squared. So that's x caret 2. And then you have to arrow plus 5. And then how do you get your table? And then you're going to press the second and the graph button. The second button and the graph button. So we just need to know what happens when x is -1 and when we let x equal 5. We need to know what our outputs are. Yeah, I'm coming to check to make sure everybody's got it in there. X squared caret 2 arrow, just like I've written up over there, arrow plus 5. And then hit second graph. Arrow plus 5. Second graph. Y equals clear. X caret 2, just like I wrote up there. X caret 2. Then use your arrow. Plus 5. And then you're going to press second graph. You want the -1 and 5. Okay. Looking for a table. Okay. So when x is -1, we got 6. And when x is 5, we got 30, right? Okay. So we're taking our, remember that this is f of 5. This is the same thing as f of -1. So f of 5, 30, minus f of -1, 6, over the input, 5 minus -1. So what is 30 minus 6? 24. And what is 5 minus a -1? Becomes 6. So my answer is 4. So find the average rate of change. I write it like this. Average rate of change equals 4. So we're going to do it again. The only thing is you don't have to change your equation because we're using the same function. Okay, we're using the same function. So when we do our table now, we have to figure out what happens when x is -6 and when x is 4. Same function. So when x is -6 in your table, what is your output? It's 41, you said? Okay. And when x is 4, what is your output? 21. Okay. So f of 4 minus f of -6 over 4 minus -6. I'm just writing this one out. So f of 4, we said was 21, minus f of -6, which is 41. And 4 minus a -6 becomes 4 plus 6, which is 10. What is 21 minus 41? Tim, what is 21 minus 41? -20. What is -20 divided by 10? It's -2. So my average rate of change equals -2. What did I do here? I took this minus this. I took this number minus this number. That's what I'm doing. Okay, let's do it again. We're going to do example number 3. Raise your hand if you need more time on this page. Okay. Example number 3. So on this side, I have a function, h of x, and it's given by the table. So we don't even have to put it into our calculator, right? They calculated the table for us. So we're trying to find the average rate of change over the interval between 2 and 6. So we always take the second one, right? So f of 6 minus, it's not actually f, it's h, isn't it? Let me fix that. H of 6 minus h of 2 over 6 minus 2. Well, what is my output when x is 6? Owen, 3. Kenna, what is my output when x is 2? I didn't hear you, I'm sorry. 9. Kylie, what is 6 minus 2? Okay. 3 minus 9, Ken. -6. So I have -6 over 4. Does that reduce? It does. I can divide both the numerator and the denominator by 2, and I get -3 over 2. If you just put -6 divided by 4 in your calculator, you're going to get -1.5. Turn it to a fraction. Turn it into a fraction. That's your math button. And then you just press the enter button twice. The first one says, do you want your answer as a fraction? The second one gives you your fraction. So our answer is number 1. Hopefully you guys know that -1.5 is the same thing as -3/2. Hopefully you know that. Okay. Raise your hand if you need more time. Okay. Last one. Skylar is selling glasses of lemonade. The function g of t models the number of glasses she has sold after t hours. What is the average rate of change at which she is selling lemonade? So let's see, t is my input, g of t is my output. So I need to figure out what happens when the time is 2 hours and when the time is 8 hours. So how am I going to put this in my calculator? Well, let's talk about it. We're going to do calculator buttons. So we're going to put this in our calculator. So everybody go to y equals. And then clear it. Whoops. Y equals and clear. So I have a fraction. So that means that the numerator has got to all get grouped together, right? How do I group something together? What do I use? What do I use to group something? Not my arms, a parenthesis. So you're going to type in parenthesis x caret 2 arrow plus 4 parenthesis. You have to do that. You have to let the calculator know that t squared plus 4, all of that is being divided by 2. And then you're going to press the second graph button. So, parenthesis, x squared plus 4, coming to check. So clear it. I want to see everybody's. So you already put it in there? Okay. Can you press your y equals again just so I can see your equation? X squared plus 4, what else are we doing to that? Dividing by 2. You see how I wrote divide by 2? There you go. Now go to your table. Fix that. Can you type in what I asked? Y equals. Clear. Okay, where's your x? X's. Key. Okay, do you see this, Carla? Find that button on your calculator. 2, and then use your arrow. One time. 2, arrow. Okay? Plus 4. Okay? You have it in a parenthesis. You have to have it in a parenthesis. It all has to be in a parenthesis. So you have a parenthesis here and a parenthesis here. Now hit the divide by 2. Divide by 2. Y equals. Y equals. Y equals. Good job. Is it Ken's?
Yeah.
Okay, Ken. Let's try it again. Parenthesis. X squared. No. I didn't say 4 squared, I said x squared. Do you see what I have written up there? I need you to put an X in there. Caret, 2, arrow, plus 4, close your parenthesis, divided by 2. So if you have a parenthesis at the beginning, so let me show you how to add that. You insert it. So I wrote on the board that you needed that, correct? Second insert, you see INS, that means insert. There you go. Now you can hit second graph. I'm gonna ask you to do something. It doesn't mean let your neighbor do it. I need you to know that you know how to do it. Okay? Good job. Good job. Let me see. Perfect. Okay. So when x is 2 or when t is 2, what is your output? 4. When t is 8, what is your output? 34. Okay. So t of 8 minus t of 2 over 8 minus 2. Well, we said t of 8 was 34. T of 2 was 4, and 8 minus 2 is 6. What is 34 minus 4? 30. And 30 over 6 is 5. So what does this mean in terms of the problem? Remember that this should actually say G of T. Remember that G of T, G stands for the number of glasses, T is your time. So how many glasses is she selling? She's selling 5 glasses per, what is my unit of time? Hour. 5 glasses of lemonade per hour. 5 glasses of lemonade per hour.